Let's start with a recap from last week. What we did last week. Can anyone do the recap? You can type, either you can type or you can chat, whatever we prefer. Hear me right? Okay, yeah, we went over statistics. Yeah, that's right. Okay. What we did in statistics, what are the and what is your observation regarding that? Like you were asked to do a homework on collecting the data, right? Did you had any challenges in collecting the data? I see interesting statistics like somebody worked on the water bottle colors. That is a cool one, and you don't see a challenge. That's good. So what we did last week is we started with a set of data and we described the data. We described what is the mean, what is the mode, and all those descriptive statistics. Today we are going to go for the inferential statistics that like once you have a set of data, how you are going to analyze it and how you are going to get meaningful information from the data. So that is what we are going to do. So today's agenda, before stepping into the agenda, I want to give recognitions to all these people. They did really good in the homework. They went beyond. I went above and beyond completing the homework. Good job. And I have seen people using Python or just a notebook. Anything is fine as long as you're able to complete the homework and get something out of it. Great job, guys. Thank you. Okay. What do you think about this? What is your comment when you see this picture?
We can only see the quiz still. I don't think your screen is slideshow.
Okay. Thank you for pointing it out. Let me start sharing that. Go back to the people who did the quiz. So these are the people who did well and beyond the homework. Thank you, guys, and keep doing what you're doing. Then can you see this board?
Yes.
Yeah, we can.
Okay. So what do you think about it? What it is saying? Can you read this one? So population, feet above sea level established, and there is a total.
I feel like that's the number, that's like a rating for in which this city is like compared to according to like certain standards.
I think it's like a total, it is the total of the population feet above sea level and the year it was established. So I guess it's saying like the details of New Kuyama, and then it would be compared to like other small towns or just other cities.
So if you look at that, it is the simple board. They are talking about the population of the city and what is the feet above the sea level and when the city was established. And can you if this total means anything to you, will it give you any information?
It would not give any information if the previous thing, 3 items were not listed.
Okay, that's right. So this is just a funny thing that they did. You can just sum any numbers, but that may not give you any results. So what statistics really is, we are going to look into category. We are going to we can compare population of the city with other cities' population, right? We can do a comparison between 2 cities. But if you're totaling it, it is not making sense. It is just a funny picture in the internet. I just want to show you about statistics. Now let's go to this one. I want to give think about it. And what do you think about this picture?
I think the math is wrong.
Okay, good. So, the math is wrong. this is like 21% of the boys in total is going to support this person, and 30% of the girls are going to support the person. So when you're working on the data, you cannot just like, so that's why we need to pay more attention to
That
the
doesn't make
data.
sense because if there are 100 boys and 100 girls, 23 girls support, 21 girls support him, and 30 boys support him. So he has 51%, 51 people supporting him. But the total sample size is 200. So actually only 25% are supporting him.
Yeah, that's good. You got it right. So when you're looking, yeah, as Jonathan mentioned, you need to be really careful while you are going to look at the data, how you're going to interpret the data. So when you're reading it and interpreting it, you need to make you need to make sure you are interpreting it right. So today's agenda, we are going to talk about the correlation coefficient, correlation and causation, and regression analysis. And I received a few notices about collab. So we are going to talk about collab or Anaconda and the Kaggle database. So this is our agenda. So let's dive into correlation coefficient. So in the homework, what did you like? What is the scores that you were working on in the homework problem? So homework problem, you were working on the ACT scores, right? So we were working on the ACT scores. So what I want you to do is I want you to annotate. Like you're going to annotate and tell like what are the factors that may impact a ACT score. You know what is ACT, right?
Yeah.
Okay. So can you start annotating and say like what are the factors that may impact an ACT score? So you need to just type in, or you can draw here in the screen. Are you able to do that? Can you check?
Wait, so what are we supposed to type in the chat? Like,
Not in the chat, in the whiteboard. This is a whiteboard.
oh,
See, like Felix is typing, right? So
okay.
I want you to type like what are the factors that may impact ACT scores. So type in your answers here.
How are we supposed to type?
Felix, can you tell how they are supposed to type? You already did that, right?
You click view options on the top and then click annotate.
Thank you.
Oh, I have a Chromebook, so I don't have that option.
Yeah, I do too.
Then you can type in the chat then. You can type in the chat. Grade level, questions, reading comprehension. Okay. Yeah, how fast a student can answer questions. Yes, Meghna, good. Intelligence of the student. Okay, good. Then what are the environmental factors that may lead? Error rate, time per question. So if you look at that one score, different factors are impacting, right? Critical thinking. See, I'm just talking about ACT scores. For this one score, you have all these factors impacting, right? So what we're going to do is we are going to talk about correlation. The correlation is how this ACT score is related to any of the factors here. Let's say we are going to look at the ACT score of the student and we are going to compare the IQ of the student. How they are related? Is there any relation between that? So that is what we are going to study here. That is correlation. Any questions?
No.
So let's talk about the correlation. And so this is like, these are the examples for correlation. Like sometimes, like when you're doing more physical activity, you may lose the weight. And the utility bill is based on the usage. However you're using, you will get your bill. Like if your usage is high, the bill will be high. So can you give me some examples, like what like two factors that will impact, there is a relationship between factors. Can you give some examples? So yeah, go ahead.
Wait, you cut out for me. The audio just like messed up. Can you say that again?
So can you give some example for the factors, any factors that are that you think that are related?
To the ACT scores?
No, two factors. Any examples? Can you see my screen? I'm showing the examples here.
No, it's showing the
Whiteboard.
ACT scores screen for me.
Okay, so how about now? Are you able to see the screen?
Yeah. There we
Okay,
go.
okay. So every time I'm switching, I need to switch. Okay, I got it. So what I'm trying to, these are the examples for the two factors that are related. Can you give me like anything that are related to each other? Like let's say you're driving in a car, your distance traveled and the fuel consumption. That is a relationship between that, right? So can you give us, can you come up with some examples? Yeah, I see some preparation and speed of house.
Excuse me. I'm sorry, but like those examples, are they like correlated? Are those like examples of correlation or?
No, yeah, whatever you want, whatever you think there is a relations. Yeah, I want mental health and self-care. Okay, number of cars and the amount of traffic. Good one. Okay. I'm getting something from the chat. Good. Oh, when you get up and what time you go to school. Yeah, that's right. And efforts on grade. Yes. So these are the things you are saying that are related, right? So in statistics, we are going to check what kind of relation between those factors. That is what correlation analysis is all about. So correlation analysis is, we are going to use the Pearson correlation coefficient formula. And this is for the linear dependence. Let's say if it is just for a straight line dependence, we are going to use this Pearson correlation coefficient. And if there is curvilinear, for example, when you're driving the car, when you start increasing the speed, the gas consumption will be higher, right? Until you reach a point. Based on the research, at 55 miles per hour, the car speed and the gas consumption is optimal. Like if you're going to increase the speed, the gas consumption is going to increase, and it will decrease over time, and then it will also increase. So if there is increase and decrease, or if there is a curvilinear or any other relationship, will not be able to use it. This Pearson correlation coefficient is only for the linear dependence. That means a one-to-one relationship. Okay. So how we are going? So this correlation coefficient is called R, and I will show you how to calculate that. And we are going to talk about what is R here, the correlation coefficient. Okay. So if R value is between, like if it is less than 0.9, we are saying very low correlation. If it is between this, so this is just a guide. And the R value can be between -1 to +1. Okay. It cannot go more than that or less than that. It can be, it is the value that is between -1 and +1. So shall we start with calculating this correlation coefficient? I want everyone to do this along with me. Can we start?
Yes.
Any questions so far?
Wait, you're going to explain to us how to do that, right?
Yes, exactly. Yes. But we are not going in depth in the formula. We have our tools here. We are not going to use any of the formula here. Okay, because the formulas you will study. We are not here to study the formula. We are here to study what does that mean. Okay? So what we are going to do is, what I'm going to do show you is how we are going to calculate this correlation coefficient. So remember that data set that we used last time, the gold rate. I'm going to use the same thing, and let's do that. Daily gold rate. I need. So what I have is this annual gold rate. So this is the file that we were using last time. I'm going to use the same thing. So this is the annual gold rate. You can, do you have this file? You can download it in Kaggle. If you don't have the file, I will show you how to download it. Do you all have this file, gold rate file with you? Or do you want to download it now? So we can all do together. Okay, you don't have it? Yeah, sure. Let's do that. So what we are going to do is we are going to go to Kaggle. So Kaggle is the database. I want you to sign up for this. And in Kaggle, so when you go into the Kaggle, you're going to the data sets here. Data sets. And you can, like, there are multiple data sets here. What I did is I went and was part of education. Search here. So these are the data set I used. So I'm going to give you this thing. Let me give you in the chat. Go ahead and download this one. Yeah, thank you. So are you able to go to Kaggle?
Yeah, I got it. So we just click
You got
download.
it? Yeah, you just click download. When you download it, you will have two files, annual gold rate and daily. We are going to, for this exercise, we are going to work with the annual gold rate.
I can't find the data set. It says that like there are no data sets like that.
I think this link, did you went to this link, this Kaggle? Huh?
The link worked for me. So if it doesn't work, then just try searching in gold rates 1985, January 2022 and see if it works.
Do we have to use the annual gold rates or the daily gold rates?
Annual gold rate. For now, we are going to use the annual gold rate.
Okay, got it. Thank you.
I think for downloading, you need to register also, right? You need to register in Kaggle in order to download the data. Make sure you're registering and you can download this data. Are you all with me with downloading the data and you have the data with you like this?
Yeah.
It's annual. I'm sorry, but it's annual gold rate, right?
Yeah, annual gold rate. Yeah, we are going to look on the annual gold rate. If you're not talking, can you please put yourself on mute? So are you all able to get this data?
Yes.
Okay, so you can use either Excel or Google Sheet. Both will work. Okay, so what we are going to do is we are going to find if there is a correlation between the year. We are going to check whether there is a correlation. There is a relationship between the year and the gold rate based on the US dollar. That's what we are going to first do. So we can do this with the formula. So the formula to do it, let me make this a little smaller. I want to see. Can you all see the screen now, the bigger version of it?
Yeah.
Akhil, you need to sign in to download the data. Yes, you need to sign in to Kaggle, and we will be using Kaggle a lot. So I highly recommend you to sign in so you can download the data and work. So let's start. There are two ways you can find the correlation. The first one is the formula. So we are going to do this one. So the formula is equal to CORREL. And you need to get first array and the second array. You're going to just choose both arrays. So I'm going to choose this. So I'm going to select my first array and here, comma, and then I'm going to use the second array. And so I see this is the number, correlation number. So this is the first way. Okay. If you want, I'm going to show it again with the formula. Okay. The formula is Corel. See, that's a correlation. And we are going to choose the first array and number, this number, then comma, then we are going to choose the next one. Okay. Then this is your correlation. So all this formula here, the formula we saw in the PowerPoint, see this one, the system is doing for us. So it already gave us the value, the R value. Okay. So here is my,
I have a question.
yes, go ahead.
So when I did this, it said possible data loss. Some features might be lost if you save this workbook in the comma delimited format. And it says to preserve. Do you save it in the Excel file format or the CSV format?
Excel. No, not in CSV. Yeah, I forgot to mention that. If you're going to work on the CSV, lot of things will be missing because CSV is very limited in applications. So what I do is I save, like after you download the file, it's better to save it as an Excel or work in the Google sheet.
When it says like save as type, is it like the
file savers? Yeah,
one?
file savers. When you go to here, you have all these options, right? You can choose any Excel book, Excel macro, all first options. For I think for you may have, yeah, these are the options I usually use: Excel workbook or the binary workbook.
Okay, thank you.
You're welcome. That's a good question. Sorry, I forgot to mention about that. So you need to change that as Excel workbook. Or you can do in your Google Sheets. If you're going to do it in a Google Sheet, that's okay too. It is the same thing. You need to just do with the formula.
I have a question.
Yes.
So it just, my computer's taking really long, but it downloaded. So how do I get it to like on Excel?
You
Do you have Excel in your system? Do you
Yeah,
have
I
Excel?
do. Yeah.
Okay. Can you share your screen? I can walk you through. I'm going to stop sharing and you can start sharing. So everyone can see that. Who was speaking earlier?
Oh, it's Akil. I'm speaking.
Yeah. Okay.
It says host disabled attendee screen sharing. I can't.
Okay, let's do that. On participant, let me change it. Yeah.
Okay, it works now.
Okay. Yeah, let's do that. we'll be using Excel a lot, so
Did you save yours as an Excel workbook or an Excel binary workbook?
both will work. It doesn't matter. So
Can you see
open the
Excel?
yeah, I can see the Excel. Can you open your CSV file? Where is your CSV file?
The what?
The CSV file, the annual goal rate. Where is it? Your download.
It's not showing here.
Oh no, go to your My Documents. Go to your My Documents. Go to folder and open. Click open on the bottom.
Okay.
Open and go to My Documents.
Documents.
Your My Documents and
Oh, I think
downloads.
I think it might have saved. I might have accidentally saved it somewhere else. Let me see.
Okay. Or you can in the downloads. It will downloads. Go to the downloads on the top. Yeah. Downloads and. So
there
if
it
you archive, right, and annual goal rate, open it.
Is it CS? Oh, that's just there's two.
CSV, yeah, that's a CSV, and open it, and you're going to save this as Excel.
Okay, and then I save it as.
Yeah. Yes, file. I think click on the home. Click on the home.
Oh.
Home. Yeah, save as.
It's not.
No,
I can
on the
save
file
it.
format. You were right. You were there.
Yeah,
Click
I
on the
can
file
save it right
format.
here.
Okay.
Yeah,
Here,
down
okay.
below.
And then I just save it as a download.
No, wherever you want to save, which place
Okay.
you want to save.
No, when it says file format, instead you pick something that says Excel.
Oh. This?
Yeah, just click Excel binary something.
Okay.
The first, yeah.
Okay.
Why are you doing Excel binary? It's just XLS, right? You don't
Excel is okay too. Excel binary will have more options, and with binary, the storage size is really small. If you see with the regular Excel, your file size will be really bigger. It will occupy more space. So when you are doing with the Excel binary, it is already compressed.
Okay.
So you can choose both. For what we usually do the binary option because the space consumption.
Okay.
So Akhil, are you good, right? You have your file, right?
It's open. Yeah, it's right in front of me.
Okay, anyone has issues with downloading the file and getting the file? Okay, if you don't have, we can start. Let me start sharing again. So here is the file, right? I have my file, and this is from our last week. I was showing how we are doing the analysis, right? Right now, we are going to do the correlation in the same way. So there are two ways, as I mentioned. First, we can just do with a simple formula. The formula is going to be equal to correl, and then you have that. You're going to choose two arrays. If you see, we are choosing two arrays here. So I'm going to the first array, then come back, and I'm going to choose.
So for the first array, would you do the date, and then the second one with
Yes. For now, because we are going to analyze whether there is any correlation between the date and the US dollar. Like as year passed by, we are going to check whether there is an increase in the US dollar, the increase in the price. That's what we are going to check now. Okay, for this exercise. So are you good? Are you able to find, are you able to follow this one, this first step? You're just using the formula.
Yeah, but when I get my number, it says 0.802831, but it just stops there. So how do I expand it?
What happened? It says 0.802.
It just stops after a couple digits.
Digits. Probably you may need to click on this one. You can decrease the decimal or you can increase the decimal just like this.
Can I see how you did the correlation command again? I got
sure.
the equals correlation. I just
equal to CORREL.
Yeah.
So what and parenthesis, open parenthesis. And
I just need to see what's in parentheses.
Two arrays. So my first array starts here. So from here, I'm going to control shift and down arrow. That will give me the whole thing, the whole until the end. Then I'm going to type a comma. So I'm scroll up. So type a, like when I type the comma, the first array is done, and I'm going to do the second array. So I'm going to place my cursor here, shift control down arrow, and then go up. You see this, and you're going to close the parenthesis. So that's it. Do you want me to show again?
No, I got it.
You
It
got
shows
it?
the number.
Okay.
Yeah.
Any questions on this calculation?
For mine, it only comes up until 802,831, but doesn't show the rest.
Oh, did you try this one, the decimal increase? This the icon here, see here on the top number, and you see decimal increase and decrease.
When I do that, it goes to 802,8308.
Oh, 8. It is stopping from here. So you need to do it one more time. So if you want, you can just click like how many times you want. You can.
If you want to redo. No, you might have to increase your cell width. The width of the cell will dictate how many you see. So if you expand it, you will see the full numbers.
Yeah, this one too. So yeah, that's a good.
Yeah. So if you decrease, it will just round up to visible.
So until how many places do you want us to?
We want just two, or like we want like this is enough. 0.80 is enough for me.
Okay.
Yeah. So if you're good, can I show you the other method?
I'm sorry. So like the first method was to like type Corel and then like you and then
The
use
array,
the two.
yeah, two arrays. Yeah, that's it.
Oh, okay. All right. Thank you.
So I'm going to paste it. See, I'm going to show the formula here. So if you want, you can take a screenshot of it. I'm just showing the formula here. Or other way to do just
Where are we gonna find with this
pardon? Go ahead.
the formula?
Can you we are finding the correlation coefficient. So yeah, as I mentioned, the correlation can be between, it can be any number between -1 to +1. This R can be only between these two numbers. And if it is negative, we are saying there is a negative correlation. That means when one variable increase, the other decrease. If it is the correlation is 1, we are saying when one variable is increasing, the other variable is also going to increase here. So so we are finding the R, okay? And we are finding the R, and we are saying if there is a correlation or not. If R is equal to 1, that means we have a perfect positive correlation. That means when one variable increases, the other also increase. Let's say you're going there is an increase.
So if it's a higher number, then its correlation is bigger.
The correlation can be between only -1 to 1. It cannot go bigger. So if it is 1, we are saying it is a positive correlation. If we are saying it is -1, there is a negative correlation. So that is what we are going to do. So see, what we did so far is we identified the price, right? So what is the value we got here?
So we got something like 0.802.
0.8, right? So 0.802, right? So what does it mean is it is going to tell us there is a positive correlation. By the year increase, the price of the gold is also increasing. Then, so as the time passes by, the gold price is also increasing. That is what we are saying here.
So, but it would be a very high correlation.
A very high correlation. You are right. There is a very high correlation. So let's do this in the graph, and you can see the correlation. So I'm going to insert and a graph. Scatter plot, I'm going to do the scatter plot here. So if you want to show me how, like how I did, I'm going to do it again. So what I did, I chose these two columns, column A and B, and went to insert, and I clicked on the chart, and the first chart, the scatter plot. The scatter plot, it is, if you look at that, when the time goes by, it is going this way, right? And we can also do a trend line here. So when you click on this, you can add a trend line. So when you click on the dot here in the scatter plot and add a trend line, so it is going to see the trend line. This is, the trend line is showing that there is a positive correlation. See, it is going up towards this way. So here, you can see this is a scatter plot. So if the line is going this direction, that means there is a positive correlation. If the line is coming this direction, we are saying there is a negative correlation. So with our analysis, what we did here is we did the trend line and we did the correlation, and we are saying there is a positive correlation between the time and the goal.
If it was a negative correlation, and if we had like let's say it was negative 4.32
Yes.
or something like that, then it would
Yes.
be a negative moderate
Exactly.
correlation. Would you keep the
Exactly.
moderate? Okay, you just add negative to it.
Yeah, if it is a negative, we are saying there is a, when one item is going up, the other item will come down. So if you want, let's do that. Let's say the price and the quantity. So let's say if you're going to buy, so let's say you're going to buy one item, your price is going to be 10. And if you're going to buy two items, they are going to give you a deal. It is going to be 18 to 18. And for three items, let's say they are going to give 5. So I'm just coming up with the numbers. So if I'm going to plot the graph for this, you will see a negative correlation. Sorry, it is a positive correlation. Okay, it is a positive correlation. Well, back we can see the negative correlation. Okay, let's say this one. The temperature and the ice cream sale, that will be a good one. So when the temperature goes down, that will also, so can we give an example where there is a negative relationship between variables? Can you come up with anything?
Would it be like from like a bigger quantity to a lower quantity?
Yes. So let's say distance travel and the fuel consumed. So when
the
you
miles you drive and the amount of gas.
yeah, that's right. That is the one thing. That's a good example. So let's say so when you're traveling more and more distance, like your fuel will be coming less, right? So there is a negative correlation. So in that time, you will see there is a like inverse relationship between the number of miles travel and the fuel consumption. So in that case, you will see there's going to be an the scatter plot is going to be something like this here.
Right.
So we will see, yeah.
I'm just saying, even though it's negative, we would still keep the different like categories, like low, very low, moderate, high. We'd still keep those categories, even if it's negative, right?
Yes, exactly. Yeah, you're right. So even if it is low, so you are going to check whether it is a low correlation, low negative correlation, moderate negative correlation, or so we are going to check the category. And so the R value will tell us how they are related. If it is a minus and if it is closer to 1, it is a negative, perfect negative correlation. If it is a plus and is closer to 1, we are saying a positive correlation.
Okay.
Okay. So this is about the correlation. So let me show you the other simple method in Excel that we can calculate the correlation. So we did it by the formula, right? So what we can do is we can also use the data analysis tab. When you go to data analysis, here. Yeah. So in the data analysis tab, your data analysis, you're going to click on the data analysis, and here you're going to look for the correlation. See the correlation and click OK. But for this one, you need to have both the variables at same, like close to next to each other, adjacent.
How did you get there again?
This one, the data analysis, let me
Yeah.
answer this one. So data analysis, if you don't have the data analysis, you may need to add this. Who was talking again?
It's Meda.
Do you want to share your screen so I can walk you through how to get? Do you have this data analysis in your system here?
No.
Okay, so can you share your screen? I can walk you through.
Mine's on
Sure.
home, so.
Oh, yours is on Google, a Google Sheet. I'm not sure how to.
No, I said home, like the home tab in Excel.
A home tab in Excel. You have it in
It looks
home tab.
different.
Okay.
It looks really different.
Okay. Probably you have the newer version minus like
I
2015.
have something that says analyze data on the home tab. Is that what you're talking about?
Yeah, probably that may be the right place. Yeah.
No, it should say data analysis. It should
Oh.
be there.
Okay.
Do you need still help or you're good? Click on that, whatever that shows in your homepage, check on the data analysis and check whether it is showing some values like this. So when you click on that, you need to see this child window. See this child.
Yeah, I don't see that.
See that? Okay. So
I think I probably have the newer version. Can I share my screen? You can walk me
yeah,
through
sure.
it.
Yeah, sure. Yeah. Can you share your screen?
Yeah. So this is what I have. I'm on the home.
Okay. So analyze data, click on it. Let's see what it is. Yeah, click on it. It's coming. Oh, it is just giving you the whole thing. You don't need to do anything. Okay. Can you go to the file on the file? Click on the file and go to options on the bottom. Yeah. And let's look at that trust center. Look at that. Sorry, add-ins. And here, see the analysis tool pack is inactive. Can you see this? It's inactive on the in the middle. Yeah, click on that one highlighted. Yeah, click that the analysis tool pack, the first one. Yeah, see it is inactive. So what we are going to do is we are going to make it active. So on the bottom, you see Excel add-ins, right? The tab, yeah, click that. And you want click go. Let's see what's happening. Click go on this one and click the analysis toolbar. Click that one and click OK. And then you will see it in the data tab. Go to your data tab. You see the data analysis because it was not enabled for you previously.
Okay,
Anyone,
that's everything.
Okay. Anyone have same issue? If you don't have issue, I think we can start. Let me start sharing and okay, let's go here. Right. So what I'm going to do is I'm going to the data tab and the data analysis. I'm going to click here and I'm choosing the correlation here. So because we are previously last time we did the descriptive statistics, right? Now we are clicking the correlation and click OK. Then you are going to give the input range. Here you're going to give both like A and B. So I'm going to start from here, Control Shift down arrow, and I want, so my input is done, my output. So my output, I want this to be somewhere here. So I choose this location and click OK. So it is giving me the correlation. Okay. Do you want, can I show it again one more time?
Yeah.
Okay, let me do that one. one more time. Delete this. So first step is you're going to data and the data analysis, and you're choosing correlation. You see this correlation? So I'm choosing this and click OK. Then what I'm going to do is I'm going to give the data range. I'm going to give the data range here. So I want from these two columns, and I'm choosing both, and Control Shift down arrow, I'm going to get everything. Then I'm choosing my output. The outputs I want somewhere here. See, I want my output here. So I'm going to click OK. So first you're going to choose the input range, then the output range, and click OK. So you'll get the correlation here.
Would the input range be the first two columns? And then what
Yeah,
would
first two columns, because we are looking at this first two columns, right? Let's say you want to analyze the column A and C, then you need to move this to here, adjacent to each other. When you're doing in this method, when you're using the data analysis, the columns need to be adjacent. But when you're doing with the formula, you can have anywhere in the worksheet. That is the difference between two methods.
What's the output range again?
Oh, yeah.
So output range is, let me do it again, one more. Output is where do you want to show the output? So which, like where do you want to, so all my, let's do this one. Let me insert some space here. So I want my, and this is clear. So what I'm going to do is I'm going to go to the data tab, data analysis and correlation. Then when I click OK, I'm going to choose the data. Okay, my input, this is my input. Okay. So my input is going to be here. And the output is where you want to see the results. From now, I want my results to be displayed here. Or let's go up. I want my results to be displayed here. So this is the output. So wherever you want your output to display, you can just use that. Otherwise, if you want a new workbook, you can do the new workbook worksheet. But I want it in the same place, so I'm choosing that. When I'm clicking OK, I'm getting my correlation. See, this is the same correlation. We got it from the formula.
So I just have a small question.
Yes, go ahead.
Would this, so in which scenario would this be like used in like real-time like scenarios? Like, if it was a real-time scenario, what would correlation be used?
Okay, let's say you're analyzing some data set. Okay? So let's say you're analyzing the home sale price for that area. How many, like what is the sale price of that home? So what are the factors that may impact the sale price? You may see the square, the
schools around that area.
the school, and I'm looking for some quantitative data, like how many bedrooms they have, and what is the square footage, and which area which year it was built. So all these factors will influence the sales price, right? So we want to check whether that factor is influencing positively or negatively. Whether the square foot, when the square foot is increasing, is the price is increasing, and whether it is having a positive correlation, whether it is what level of correlation it has, what kind of relationship it has. Let's say the correlation is less. If it is when the scatter diagram is all over the place, that means there is no correlation. When the scatter diagram, we can pick a trend line like this, there is a correlation, there is a relationship. So that is what we are going to decide. So in real life, we will be analyzing multiple factors. Right now, I'm just talking about the one factor, but in real life, we'll be analyzing multiple factors.
Got it. Thank you.
So that is what we will do in the real life. And then we will talk about correlation and causation. So there may be some relationship, but does that mean that is causing the event? That is not true. So here is a real life example. So see, there is a relationship between the ice cream and sunburn. There is a correlation. There is a relationship. So when the ice cream sale is more, sunburn is also more. But does that mean that what this is causing it? It does not, right? The ice cream sale is going up because of the summer hot weather, and sunburn is causing because of the summer weather. So in real life, we may think that if there is a correlation, there is a causation. We like mostly we'll assume that, but that is not the true case. So you need to know what is correlation and causation. Correlation is just we are finding the relationship between this. If one variable increase, is the other one increases or decreases. That is the correlation. Causation is like whether that one factor is causing the other factor. Whether A is happening because of B. That is the causation. So just when you're analyzing, you need to be really clear what is correlation and causation.
So
Okay.
causation is like, oh, I'm sorry, but like causation is like what reacts to something, and then
Yes,
correlation is like
the
two factors,
relationship. Yeah,
all the
exactly.
relationship.
Yeah, some relationship. So let's say there are multiple, in the example here. Yeah. So your physical activity, if you're more active, it may cause a weight loss. But weight loss may be related to other things also, right? So uh, you need to find what is it as a causation or it is a correlation. Analyze the data based on that. So by experience and with having some subject matter expertise, you will be able to find the correlation and causation analysis. So just to sum up, correlation is just simply a relationship. We are finding what is the relationship between A and B. And whereas causation is checking whether we are whether one factor is impacting the others or one is caused by the other factors. So we are going to check. You need to. There is a fine delineation between the correlation and causation, right? You need to understand that why we need to study correlation and causation. Any questions?
So correlation would be like basically if let's say A is like the input, B would be the output, but then causation is B is the output because A is the input.
Yeah, we can say that one also. So let's say if correlation is like if A is increasing, how much B is increasing, yeah, or if A increase, whether B is going to increase or decrease. That is the correlation. Whereas causation is A is happening because of B, or B is happening because of A. That is called causation. Sometimes when there is a causation, there is a correlation, of course, but it doesn't mean that when there is a correlation, there is always a causation. We cannot say. So you
So
need to
example
find.
of causation would be the car runs out of gas, the car stops.
Yes, that is causation. Yes, exactly. Good example. So any questions a bit with the correlation and how you calculate the correlation?
This is, I think this is kind of irrelevant, like, but for, you know how like for like you found correlation on the Excel sheet, how are we supposed to do that on Google Sheets?
Google Sheet, let me show you. Google Sheet is, I know the first way we can do it in the Google Sheet, but I never explored the second way. Let's. So I see the formula here, but I never explored how we can, if there is a data analysis tab that we can use. Let's do this. So I'm going to copy this over there in the Google Sheet. So I have my data here. So here, if you look at that, so here you have the function, right? So the function, and we are looking at the statistical. Here you will see the correlation. See, where are correlations? See its correlation. So Pearson correlation. So we are going to get the data here. They are asking about y and x. So your y is always going to be the dependent variable, and x is going to be the independent variable. So data y is going to be this. X. So you did that. So this is your correlation. So same thing. Instead of arrays, you're going to choose. Here you're choosing the y value, sorry, the x value first. The y value first and the x value the second. So x is your independent and y is the dependent variable. So in Google Sheet, this is how you will find it. Any questions?
Okay, thank you. And why do we take the two columns to find correlation?
So we are checking whether there is this first column is the period and second column is the gold price. So what we are trying to do is here, as the time goes by, if whether there is the relationship between the time and the gold price, then the that's what we are trying here. Like if there is a relationship between these two variables, we are trying to find. And after our analysis, we are saying, yes, there is a relationship and there is a positive relationship. That means when as time passed by, the gold prices also increased. So that's what we did.
Okay. Okay, thank you.
So, yeah, I think it's time for a break because next topic is regression. So we already did the correlation. So next topic is regression. I think it is a good segue for a break. So let's meet at 11 a.m. PST. Let's go for a break. Welcome back. I think we can start now. Any questions on the correlation?
Actually, I have another question.
Sure.
Will this recording be shared with us if we need the stuff for homework?
The thing is, we have a backlog in recording. The last week recording was already done and it is already not sure when this will be available. Yes, still having a backlog in the recording.
Oh, okay.
So we talked about correlation, right? What is correlation? Can anyone tell what is a correlation?
But you want us to explain it?
Yes. Yeah, relationship between two factors.
It's like basically a statistical relationship between like two factors in data.
Yeah, that's right. So right now we find the relationship, right? We are just finding whether there is a relationship and we are finding whether there's a positive or a negative relationship. Then once we find the relationship, we want to find, like if I have one set of data, will I be able to predict the other set of data? So that is what we are going to do with the regression analysis. So with the scatter plot and the correlation, what we are doing is we are kind of fitting this line, right? The trend line, right? So what we are trying to do is, let's say if I'm going to give, I need to forecast the gold rate in the year of 2030. Like, will I be able to do that? So that is what we are going to find here in regression. So in order to find that regression, see, we already have this line, right? So have you learned about the line equation in math? The equation for line?
Y equals mx plus b.
Yes, that's right. So we are going to use the same thing here. We are going to use the same thing. We are going to find the x-intercept and the slope of the line. And based on that, we can predict what will happen in 10 years, what will happen in 20 years. So that is what we are going to do in the regression analysis. Okay? So the regression and the difference between two measures is the correlation is telling whether there is a relationship and what is the degree of the relationship, whereas a regression is we are checking how the one factor is going to impact the other. So when
So-
you know, yeah, come on.
Is regression the same thing as causation?
No, causation is finding we are finding whether it is a root cause, right? The regression, the linear regression is we are going to say, let's say if I'm going to impact the value of x in such a way, what will be the value of y? That is what we are going to find in regression.
Okay.
So we are going to find how like like if I'm going to add like 5 units of x, what is the value will be y? What is the value of y? So that is what I'm going to find. Like how one variable others affect the others. And we are going to just look at the linear regression and just a simple regression. We are going to find just the simple one with this line graph. Okay? So that is what we are going to find. And for the regression, what we are going to do is we are going to predict the effect. That is what we are going to use the regression, and we are going to use the least square method. And then you are going to find the regression equation and predict the future. So let's start here. So you have this, right? You have this, right? You have this data. We are going to use the same data and we are going to use the regression here. So let's do the same, let's go here. There is a quick way to do the regression is you can, when you have the scatter plot here, when you click on this one, you can ask to display the equation on the chart. Can you see this, like when you click on this trend line, can you see these options in your workbook?
Yeah, it'll say display equation.
Display equation. So if you click on that, it is going to give the trend line. It is going to give the equation. It is like your line equation. Y is equal to mx plus c. Regression is like how you're going to check how one factor is impacting other, how this x change in x is going to impact the y. That is what we are finding in regression.
Isn't that causation as well?
No, it is not causation. Causation is different. Like causation is we are saying A is happening because of B. That is causation. But regression is like if I'm going to change the 5 units of B, what is the value of A? That is regression.
So causation would basically mean how does one, like how is it because of the first
Yes.
happening and then correlate and
Regression is like if I change something for A, what is the effect on B? That is the regression.
What's the difference between the regression and then the R value thing?
So R value is the coefficient. So the coefficient R is going to tell you if there is a relationship between A and B. So the correlation is going to tell, see, this is the correlation, right? Correlation is going to tell so we are going to tell correlation and regression, right? So So we are going to check whether there is a relationship between A and B. Okay. A and B. So we are going to check whether there is a relationship between A and B. Regression is, if I'm going to change the value of A, what is the delta of A will impact the delta B. What is, like, if I'm going to change something in A or change something in B, what is going to be impact in the other variable? That is the regression. Are you getting it? So regression is just this. We are finding this, whether there is a relationship. We are finding the relationship between the year and the gold price, and we are saying, hey, yes, there is a positive relationship. But regression is going a step ahead and saying the line is something like this. The slope of the line is here. The x-intercept is like this. So it is going to tell us more about this line, like how it is going. So you can have a graph that is going straight. Graph. There are two graphs, right? I'm going to just plot this one in the graph and show you the regression. So we have, like, when a quantity is increasing, the price is increasing, but it is not increasing in the same manner as this one, right? I have another quantity and price chart. Let me put this one together. So when the quantity is increasing, it is going to be 10. It is going to increase in the same manner. I'm just throwing an example here. So we have like two scenarios. One is the quantity and the price, and the same quantity and price. You're going to find the correlation. Let's do the scatter plot for this one, and we'll find that one. So let's here insert and chart. Chart. I'm going to choose the scatter plot. Okay. This is the first one. Okay. And I'm going to look at the second one. I'm going to insert chart plot. So I have this. So both has the positive relationship. Can you see this? Both has the positive relationship. Let's draw the trend line. So you see both has the positive relationship. And let's get the correlation on this one. So we are going to find the correlation of this. And we are going to find the correlation of this. So first we found there is a relationship. See, if you look at this is 9.99, this is 1. So there is a positive perfect relationship, and this is also a positive relationship. So we find the relationship, but we want to know if I'm going to increase, let's say it is 4 units, right? If I'm going to increase the for 5, if I want to find the price for 5, then you need to do the regression. Are you getting it? So with the existing data, we are finding a relationship, and with the regression, you are going to predict what will happen for the other unit. When there is a change in the quantity, what will happen to the price? That's what we are going to predict. That is with the regression analysis.
So the regression isn't like what the change in the value will be, but it's like what the actual value will be.
It is going to predict. It is not the actual. Let's say there is a change in the quantity. What is the predicted price? You are going to predict it. It is not the actual price. You are going to predict it. You are going to predict by using the slope of the line. So that is the regression. So correlation is just we are finding whether there is a relationship. So regression is the next step. So we are going to check if I'm changing the value of x, what is the value of y? What is the impact of the change? That is what the impact analysis, the regression analysis.
Can you give us another example?
Yeah, we will do the example, then you will know that. Okay? So we have the regression, right? So one thing, the quick way to do the regression is just I showed you in the graph. You can in the trend line, you can add that. See this way the equation. So you are having your or you are having the regression here itself, or you can do another way. I will show you that too. This is the best way. Here in the chart, you're going to display the equation, so you have it. Then if you want, you can also do the same thing like what we did earlier, like go to the data and you're going for the data analysis, and here you're choosing your regression. You're choosing the regression, and here you need to know, see, y is the value that you want to predict. X is the value you already have. So here the X is the quantity and Y is the value that you're going to predict. You want to predict the price and X is the value you already have. So we are going to just input the Y range. So Y range is this one. So I'm going to do this. Y is this and X. So I'm going to do this X. So I have this X and Y. So I want you can ask for the residual, so it will give you the residual too. And you want your output range is going to be some, you want it here. Let's say you want it here. You want the regression analysis done here in this output. So you're starting with your input, then you're going to choose your output range. Then when you click OK, it is going to give you the regression. So it is going to give this one. This is the key factor. See, what is the intercept and what is the x variable? That is your slope of the line. So this is what you are trying to find here. See, this is the key value that you need in order to do this. And it is also giving you a residual output. And if you want for 5, let's say when you're 5, you know the y is equal to mx plus s, mx plus c, right? So you are going to do the same formula. So we are going to find the y and the charge, this one. Okay, I can do that one more time. I will finish this and I will go back again. Okay, so let's do this. So we are going to find the value for y. And we are going to use this equation. So it is 6x plus x plus 4. So 6.7x. So let's do that. So which is equal to 6.7. Our x value is 5. Okay, we want to predict for 5. So times 5 and plus 4 plus 4. So this is what we are going to find for the y. So this is then the y value will be this. So for the units of 5, you're saying the price may be 37.5. That is what we are predicting. Okay. So with the equation, we are substituting the values in the equation and we are predicting the value for the next one. So if you want to get the price for 6, you are going to substitute instead of x, you are going to substitute the price. Let's do from the beginning. I'm going to restart this one. Okay, let's do this. One moment. I'm going to insert. So I'm going to restart the chart and I'm going to restart the analysis for you, just to give you a more understanding of how I'm doing. So here in Excel, you need to go to insert, then the chart, this chart. This is the scatter chart. So this is the scatter plot. So we are going to use it. So when I go here, I'm going to select this range. This is the range I want. This is the label. So we want from, this is the given data, right? So we are going to plot the graph for this. So I'm going to select this and go here and click the scatter plot. So that is the first step. And when you click on the dot, it will tell you what you want. See, on the dot, and when you right click, you see the trend line. These are the options available. you're doing the trend line. So you did the trend line. Then in the trend line, you want to show the equations. So here, if I'm clicking on the trend line and go to this graph, this one, see 3 tabs, right? This is the graph. I want to display the equation of the chart. So this is the equation. This is the regression equation. Okay, y is equal to mx plus c. So this is what we did. See this. Y is the dependent variable, x is the independent variable, a is the intercept, and b is the slope and residual. So this is what we have. So
What is the regression formula used for?
the regression formula is used for predicting the future. Let's say here we have this quantity, right? We want like what will be the price if my quantity is 5? What will be my quantity if the price is 6? What will be my price when the quantity is 10? So we are using this regression to predict the future. Or we are going or predict like what will be the impact on one, like if I'm going to increase the quantity, what is the impact on the price? I'm going to use this regression formula to find it. So the first way to find the equation is just with the chart, the scatter plot chart, and with the equation, just this one. And the second way is go to the same thing, data analysis, and you're going to do the regression. I'm going to click OK. Here the X value is what you have the independent, and Y value is what you want to predict. So the X is going to be this one. The X is going to be this one, the price, the X, and Y is the value, the price. And we have this, and the output, let's say I want my output to display somewhere here. I want to display my output in column B and row 7. So I'm choosing this and clicking OK. Then I will get this one. And with this here, we are just looking at these. See, this is the key for now. But we will be using it later, like this, all the significance and p-value later. But for this analysis, we are just going to use these two. So this is nothing but the equation. See, these two are needed to construct the equation. Once you have the equation, you can substitute the value of x and find the value of y. Are you good?
How do we do this on Google Sheets?
A Google Sheet, I tried it. See here. Let me go to my trial. So this is the sheet I was working on earlier, right? The price, right? So what we can do here, if you want a chart, I can see the chart. Let me show you. So if you want to get the chart, what you can do is you can insert chart and you can create the chart like for with like you can choose whatever you want and create the chart. Let's do want the chart for this. Insert chart for this. So this is my chart. The trend line. But I'm not sure how I can add the equation here. You can Google it and find it. If you can find it, you can just oh, it's here. See trend line. I have the trend line. Yeah, this is the trend line. Let's look at the show R square. Someone was saying something right.
Yeah. So what how did you find the equation of the line, like for the
Excel or in the Excel or in the
yeah, the Excel.
for Excel? So this one you don't need to find like it. Let's do it again. So I have this chart, right? When you click on the trend line, see the trend line, you have this options here. So you just need to choose this display equation on chart.
Okay, got it. And for the trend line, you just after you create the graph, you just it's an option to create the trend line, right?
Yes. So let's do it again. I will do it in Excel first, then we'll go to the graph. So here the Excel, we have this one, right? This is the area you're going to plot the graph. This is the area. And go to insert and this chart, this scatter plot, this first one. So click on this. Then when you click on the dot, you can just click here and right click. When you right click, you have the option for the trend line. So I'm choosing the option. So trend line is showing.
Okay, so you just create the graph and then right click the graph and then you get the trend line.
Yes. Then you display the equation on the chart, then you will get this one.
Got it. Thank you.
So let's try the same thing in chart. Sheet. This is my data. So I want to insert a graph. So I'm going to insert. I'm going to chart. And so when you click on this chart, it is plotting it here. So can we choose the chart? So I don't want the line chart. I want a scatter. See, this is the scatter chart. So this is the scatter chart. I have the scatter chart. Then what I'm going to do is I'm going to click on this one. It is going, when I click on the point, it is going to show me this. So can I add this time? I want to add a trend line. We want to start a chart. The option. Or let's Google it. That's it. So let's do that. So we have this, right? We have this. We want to add a trend line. Trend line. See, so you're going to double click and customize. Okay. Chart at the right. Customize. Chart. So you have the customize here. Series. Here. See trend line. See, can you see this? You're adding a trend line, you have the trend line. But the equation, I'm not sure how we can. Just giving R2. Let's do the same thing. You want the equation of the line, right? This is the equation of the line. So
There is a suggestion on chat.
Okay, let's see. The equation plus label, change it from to show equation. Okay, that's good. So, plus label. Okay, that's label then. So, change time series. So label, where do you want to label? For data labels, this one.
No, if you scroll down, there is one more label.
One
there.
more.
There, the last one, above that. Yeah, 1, 2 below.
Oh, label. Okay, here, use equation. Okay, thank you. So what we are doing here is, let's do one more time with the chart sheet. So I'm going to this one. So we have this price, and I'm going to insert chart. I want this chart to be scatter plot. Chart. So I want to be scatter plot, and I want to show this series. I'm going to label. Series. So are you able to follow this? What we did so far? Get the equation in Google Sheet. Or you want me to show one more time?
Can you show like one more time, please?
Okay, let's do this. I'm going to use this data. This one, gold one. So what we are going to do is we are going to use this scatter plot, right? So this is the data. Let me choose A and B. And go to insert chart. I have the chart here, and I want my chart to be a scatter plot. Scatter, this is the scatter. Then I'm going to double click here, and in the series, when you go to the series, you are going to do two things. One is the trend line. In the trend line, we want this to show the trend line. This is the trend line. And then the label you want is the equation. So now you got the equation. Okay? So this is the equation. So what we are going to do with the equation, right? Right now we got the equation, right? What we are going to do with this. So let's say you have the years, right? I want you to predict the data for other years. Can you predict the data for 2030? What will be the price of the gold in 2030? So you're going to use this equation to find it. The x is going to be 2030, and you're going to add this value, and you're going to find the value of y. Okay. So that is what we are going to do. Yeah.
And then like that value would be the regression.
That value will be the expected value. That is what we are saying. We are predicting that to be we are predicting that as the value for that 2030. That is not regression. So the regression will be this one. The R square is in a regression, and these two are the key values that we are going to use in regression analysis. So we are finding the equation, that is the regression. We are finding the slope of the line and the y-intercept, that is what we are trying to find with the regression analysis.
I have a question.
Yes.
So how did you get the graphs that are on the side of the graph? the summary output graphs.
This one in Excel or Google?
She used data validation and she just used regression.
Oh, this one?
Yeah.
Oh, you missed it? Okay, let's do that one more time. So just wait a minute, let's do. So what I did is I like you need to go to the data tab and go to the data analysis and choose the regression and okay. And here you need to give the values of X and Y, then output I want and the output range, then that when you click OK, you will get this.
Okay, got it. Thank you.
So you can either you can find with this data analysis or with the graph. So this is going to be the homework I want to assign this time. Okay. So I want you to find the regression between date and the European currency. So not forget about this for now. So we already used it in the class. So I'm just going to hide this. So in the in your homework, you're going to find the regression and the correlation for these. And I want you to predict the value of gold in 2030. So you are going to find the value of gold in 2030. And that is your homework. Any questions on the homework?
So we're only finding two questions. So we're only finding regression
and correlation. You need to find correlation, regression, and the price of gold in 2030 for this data. For European currency, I wanted the euro. Not with the US dollars, I want with the euro. So let's get rid of this one and you're just going to find the correlation and regression for these values and you're going to predict the price for 2030.
Is that our homework?
Yes.
Okay, so just for Europe, we have to find the regression and correlation.
And predict the gold price for 2030.
Okay.
So in 2030, what will be the value of the gold in European currency?
Okay.
Yeah.
Is this due by is this like same as last time, like next
Yes,
Saturday?
exactly. Yeah, it is due by 22nd and it is due by 22nd. Any questions on the homework? I will be publishing it. Yeah.
Oh, sorry.
Yeah, go ahead.
Oh, it's due on Tuesday on the 22nd?
Yeah,
Okay.
22nd. Yeah,
Okay.
February 22nd. Yes, February 22nd.
So by regression and causation, do you mean like the charts that we made or like just one number?
Regression, no. So you're going to, it's better to get this value. I want this equation. So by regression, I mean, I want you to find what is the value. Here, see, I want this one. Y is equal to what is the slope of this one? I want, like, what is the correlation? And I want you to find this equation. And use the equation to find the value of gold in 20.
So for the correlation, is it just like the number?
The number, just the number. Yeah, just the number.
So
Yeah,
the correlation
whatever the
is the number, and then the regression is like you want us to find the equation.
Equation, and then you're going to predict the value of gold for 20.
Okay.
Got it? Any questions? You can use any tool to find your own correlation and regression and the equation. And even for the prior homework, I think for 3 people have attempted in Python, good work. So whatever tool you want to use, or you can use a Google Sheet or Excel. If you're going to, you don't like when the Excel, if you want to just save this Excel as PDF, you can just do that and share it, share as the PDF. Whatever way you want. The main goal of the homework is I want you to get your hands dirty with analyzing the data. That is the main goal. Any questions? So we talked about the regression, right? This is the graphical representation. So you are always you will graph your independent variable in x and your dependent variable in y, and this is the equation that you are fitting. This is the equation you are going to create for the regression analysis, and with this equation you are going to predict the future. Okay, and I want to just congratulate these people who got the top scores in today's quiz. Good work, guys. And shall we move to the quiz? Like, shall we discuss the quiz questions now? Let's do this.
Yes.
Okay, so let's do this. So I have these numbers, right? These are the numbers I want you to find, right? So let's see, let's take it to Excel and solve it together. So instead of typing what I did, I have these numbers, right? So I'm going to separate this by comma separated values, and the lecture notes and presentation, it's kind of a work in progress. I don't want to post now because if I'm going to change anything, I want the updated version available to you. So Shravya, I will be posting after the class, the lecture, the presentation. So let's hear. So this is the number, right? So for me, I don't like typing. So what I did, I just went here and I want my data to be separated. So I know what I'm going to work on. So this is my data. So, I'm going to paste it here. So I'm going to paste it here. And, I have all my numbers. So you know the right, like we can do the descriptive statistics. So I'm going to go to the data tab and the data analysis, and I want the descriptive statistics. Yes, and I want the input of this. So I have this, and my output range is going to be somewhere here. So I need one more. Yeah, I need the summary statistics. So here. So all my summary is here. So this is my mean, standard error. I don't know the standard error. So this one, see, I have my mean, I have my median, mode, everything is here. So this is just an easy way to find all the values, max, all this. I think these are self-descriptive, right? Don't find any issues with finding all this, right? Mean, median, mode. Which question have you had an issue in the quiz? Which one?
The last one.
The last one. So the empirical rule. What empirical rule is saying is, yeah, like 95% of the score will be between mean plus 2 standard deviation. Pardon?
The website, like what it does is like it. So like when you click submit, asks you do you want to, it like I said no, but it's still submitted anyways.
I don't get it. Can you please repeat?
Like there's a website glitch.
Website glitch, yeah, we'll see that. Okay, so right now we are talking about the question number 10. So 95% of the score will be between mean and the sigma 2 sigma deviation. So if you do you recall our prior lecture notes? And that the page, so it will be easy for you to. This one. Let's wait for this to open, and I will show you, and I will show you how to calculate. The reason why we need it, that is really helpful for our estimation. If you look at this one, see, 95% of population will be and these two standard deviation. And I think, I think this is the one, this empirical formula. So we are saying that 95% of data will be within the mean plus the standard deviation. So let's calculate it. So here we know what is mean, right? We have mean and we have the standard deviation. So standard deviation is going to be standard deviation. So what we are going to do is we are going to just multiply that, right? So standard deviation is going to be 2 times this one, the standard deviation. And this 95% is going to be mean plus 2 standard deviation or mean minus 2 standard deviation. So the higher range is going to be this mean plus the standard standard deviation. This is going to be the higher value, and the lower value is going to be mean minus this 2 standard deviation. So we are saying that value will be that 95% of the score will be between 8.96 and 32.7. So that is what asked here. So you are supposed to calculate what that 95% of value lies between. So this is the answer. So 95% of the scores. Any questions on this one? So if you want like this is if you want a 68%, you are going to just add the mean and 1 standard deviation. And if you want 99.7, it is going to be mean plus 3 standard deviation. So like when you're adding it, you will get values of the upper and the lower range. So it's based on this.
So I have a question.
Yeah, go ahead.
So for the 95%, we did 2 times the standard deviation.
Yes.
Minus the mean for the lower value and plus the mean for the higher value.
For the higher value, exactly. Yeah.
So
that's right.
What would we do for like 68%?
68, it is 1 standard deviation plus mean, or mean minus the standard deviation. So for 95.
Okay. So this so for 68, it would be 1. And
so
then
this is
what would it be for
95? It is 3 standard deviations. So
okay, got it.
For 95, it is going to be 2 standard deviation. You're going to add or minus, that is 2 standard deviation. And for 68, it is 1 standard deviation. So what you're saying is that many scores are deviated from your mean. So if it is within 1 standard deviation, it's like 68%. 2 standard deviation, it is 95, and 3 standard deviation is 95.7. Any questions on this one?
No.
Okay. So when you are, let's talk about, we have few more things to cover in the agenda for today. So let's jump there. And empirical rule is for the normal distribution. That's right, it's for the normal distribution. So let's go back to here. So what else we have? We have 2 more topics to cover. We covered the correlation coefficient, correlation and causation, regression. And right now we are going to talk about Collab or Anaconda and Kaggle. Kaggle is nothing but it's a data science platform, and it is just Kaggle for Kaggle.com. That's it. So register for this one, and you will find many interesting topics here. So there are many competitions. You will be applying for college, like colleges, right? In 2 years, this year, next year, or in a couple of years, you will be applying for the college, right? So see, there is a competition for analyzing the student essay. You can, so what they are planning to do is they are planning to do machine learning algorithm to evaluate the student writing. I find this is really interesting topic. So in Kaggle, you will find many, like lot of competitions. You can go for competitions, or if you want data set to work on, you can download any data set and start exploring it. And courses. So let's say if you don't have any experience with Python, I highly recommend take this course in Kaggle and complete it. Okay, so you will work on the code, and it is and the notebook is available in Kaggle itself. And if you want more courses, let's say you are already in Python, you can go for the like we have like variety of courses. I highly recommend you take 1 or 2 courses, improve your skills in the coding. So this is about Kaggle and Collab. So Collab is, it's a part of Google. So if you have a Google account, you will be able to just, when you type in this one here, so you will be able to get the the notebooks are available. You can just go ahead and start coding. There is no need for download. You just need to click and log in, and you can create your homework. You can create your codes. You can create. Let's say if I want a new notebook, you can create a new notebook and you can start coding immediately. Okay, so that is Collab. For this class, we'll be using Collab a lot. And if you want to explore more, if you want to do little more than Collab, I highly recommend to install Anaconda. So Anaconda, it's coming with all the packages. And when you go to Anaconda, look for the, you can just download the individual edition and get this set up in your machine, and you will have the Jupyter Notes, Jupyter Lab, or everything is available in Anaconda. So I highly recommend you get Collab and Anaconda, because we will be using both for our homeworks going forward. The first 2 classes for this data science is dedicated to statistics. From next class onwards, we will start coding. So when you're coming to the next class, I want you to get ready with the Collab setup. I want you to have an account, you need to have a Gmail account and log into Collab, and we start exploring with the notebooks, Collab notebooks. Any questions?
So we have to download Collab and first class.
Can you repeat? Sorry, I didn't get you.
We have download Collab and Anaconda for class.
You're breaking in between. Sorry, but I'm not able to get what you're asking. Again. Is it about the? Yeah, you need to download even before coming to class. You need to go to Collab and have a notebook, and Anaconda, if you can have it, that's a really great one. You can have an Anaconda downloaded and have it in your machine. That will be great. This one, Collab, you don't have. If you have a Collab, you don't need to have any code installed, so we can start coding. So for basic, we can use Collab, but when we are going beyond, I think we may use the Anaconda. And one quick request: when you're joining the class, can you please rename yourself with the right name, the name and the last name, so it is easy for us to track. That nicknames may not work, so it is better to have a full name. Zoom account. Any questions? Can anyone summarize what we learned today?
So may I start?
Yeah, go ahead.
So
Can you announce your name also?
yeah, my name is Kavan Karthikeyan, and the what we learned today was first we learned correlation, and what correlation is how the factors that influence correlation is are the factors that influence a particular data set. And then we learned what correlation versus causation was, and causation was the driving factor behind that behind the correlation. So yeah, so the correlation is what drives the data set, or like the values that in the data set, and the causation is what drives the correlation in the data correlation. And then regression, I'm not able to really explain regression, but it's got to do something related to I think it's related to the data scatter, like the scattering of data in the graph. And then lastly, we talked about Kaggle, Collab, and Anaconda, which are data science / Python platforms, which we'll be using later.
Yeah, that's what Kevin is. So the regression, if you're still struggling, we can just do this. So what we are doing with the regression is we are trying to find, like we are finding the equation of the slope. So coefficient, we are finding the relation. Regression, we are finding the equation of the line, and based on the equation of the line, we are going to predict something in future. So that is what we learned.
Got it. Thank you.
So to like just to repeat, for the homework, you are going to use the annual goal rate database from Kaggle, and you are going to analyze the correlation between the date and the zero, and then you are going to find the regression equation, and you are going to predict the gold price for the year 2030. So that is the homework. Any other questions or any other comments? Okay, then if you don't have any questions or comments, I will give you back 5 minutes and then we will meet next week. Thank you.
Got it. Thank you. Bye. Have a great
Thank
day.
you.
Wait, I have a question.
Thank you. Bye.
Yeah, go ahead.
Just to make sure the next class is 2 weeks from today, right?
Yeah, 2 weeks from today. Yeah.
Okay.
We
All
have
right.
the class. It's every.
Don't forget to subscribe and like. If you have any questions, you can email info@agoramatrical.org or comment below and we'll reply back. Maybe. And if you want to see practice things or anything about us, you can visit our website, which is basically the end of the email but without the info and the end. So bye!